What is up, people of YouTube? Back here today for a new video. Today we're going to be talking about graphics cards. So you're probably thinking, what's a graphics card? This is a graphics card. It's a card with graphics. Thank you very much. I hope you like this video. Don't forget to like, subscribe, and check back next week for a new video. Peace out. Good evening, ladies and gentlemen. Today we are going to be learning about graphics cards. A graphics card is an expansion card that uses parallel computing to output a series of images to an external display device. A GPU is a piece of computer hardware that processes graphics. A GPU, graphics processing unit. It does this by performing mathematical operations, the results of which it converts into a signal that a display can understand, and it sends that signal to the display via cable or wirelessly. Now you may be thinking, can't a CPU also do math? Couldn't we just use a CPU for everything? And the answer is yes.
So imagine this desk is a blank screen and these placeholders are lines of pixels. A CPU would have to draw the screen like this. And so on and so forth. Because it can only do one at a time. A GPU, on the other hand, can do a lot of the time. It'd be more like that. Like that.
Now, if that was a bit difficult to understand, another way of thinking about it is that a CPU is like a trumpet. A GPU is like an accordion. It can play like a million notes at a time. Okay, but how exactly does all that work? Well, all this with multiple things at the same time, that's called parallel computing, which is another way of saying multitasking, right? A CPU can multitask, for example, if it has more than one core. Maybe you have a CPU with 2 cores, 4, 56. But a GPU, most GPUs have up to thousands of cores. And each of these cores are highly optimized for specific operations. In this case, vector operations. Specific mathematical operations that are used a lot in graphics processing. A CPU can do anything. A CPU is a multi-tool. But it's not super good at any one thing. A graphics card is really good at graphics. So why vectors? Vector-based images, or vector graphics, are the most common type of graphics used in computer systems, especially video games. A regular image is a bitmap, right? Where you have a grid with pixels. Vector-based images use vectors to define shapes and curves and lines, and the images are then composed of those elements. What defines the performance of a graphics card? 3 things. The clock speed, the core count, 4, the core design, and the memory type. The clock speed is the amount of operations that each core can perform per second. The core count is how many cores you have. More cores, more operations. The core design, that's just how good the core is. Some cores are faster and can do more operations per clock than others. And the memory type is the speed of the memory. A graphics card needs somewhere to store, somewhere to read and to write the memory that it's working with, the data that it's processing. The faster that memory is, the faster the card. Okay, great. But is any of this fancy parallel, vector, multi-core, whatever, good for anything else besides gaming? Well, the answer is yes. Bitcoin, cryptocurrency, AI, machine learning, big data, anything that can take advantage of parallel processing can benefit from the use of graphics card. That is all I got for you today. I'm out of time. Please give a like to this video, even if you didn't like it, because I need to get a good grade in this class. And that is it. See you later.